Hello everyone, in this video we're going to be talking about how to find an interpolation formula for this table. So as we can notice, the distance between x is not the same, so the distance between 1 and 3 is 2, and between 3 and 10 is 7, something very different. So it's not equal distance, because if it was, you could have used the forward and backward interpolation, Newton interpolation formula, but unfortunately we don't. So you either have to use the Lagrange interpolation formula or the divided difference interpolation formula. But that if you know the formulas to begin with. If you don't, then I'm going to be actually using a very quick method that actually you don't need to memorize anything, even though if the points are more, then it's going to take more time. Anyway, so I brought this example since it's easier and I can cover it with less time and space. Okay, so now we do this, we do have this, okay? So now we need to find a polynomial, p of x, okay, which is equal, okay, to the values of f of x at these values. So like f of 1 being equal to p of 1, for example. So p of 1 should be the same as f of 1. And the same thing, for example, f of 3 should be equal to p of 3. And these two obviously should be equal to 30 because it's given, okay? So also p of 1 should be equal to 12. Okay, so now, since that's clear, so f of p of x is going to be constructed in the following way, okay? So we're going to be using a constant, so a0 plus a1, and then you're going to start actually subtracting the values of x from the variable itself. So x minus x0, which is the first value, okay? And then a2, okay? And then the same bracket, so x minus x0, which is just 1 here. And then now x minus the next value of x, so 3. Okay, so if this was, let's say, a larger table, so it had, for example, 4 points, you're going to be using a3, x minus 1, x minus 3, and then x minus 10. Okay, but since we have only 3 points, we're going to be getting a polynomial of degree 2 at most. Okay, so we're going to stop here. But if you wanted to do it for, let's say, more points, so that's how you construct the polynomial. Okay, now from here, we're going to be taking advantage of these given points. Okay, so if you can notice, like, for example, if we put the value of x as 1, then this becomes 1 minus 1, this becomes 1 minus 1, and then you can obviously find the value of a0. And then later on, if you need to, if you use the value of x 3 as 3, then this cancel out. From there, we can figure out the values of the constants. Okay, so now enough talking, let's just do it. Okay, so now if I say p of 1, okay, now p of 1 means I'm going to be replacing x everywhere with 1, okay, so a0 plus a1, 1 minus 1, plus a2, 1 minus 1, and then 1 minus 3. And again, since p of x is equal to the values of f at these points, so basically p of 1 is the same as f of 1, or in other words, just 12, okay? So like this, so 12 is equal to the whole thing, okay? So from here, it implies that 12 is equal to a0 plus, we can obviously notice that this becomes 0, 1 minus 1 is 0, obviously, and this also becomes 0, so we're going to be left with this. And from here, obviously, a0 is 12, okay? So that's our first result. And then we can actually use the second point. So I'm going to be, again, these are concluded from the first equation, general equation. So now p of actually 3, okay? So p of 3 is equal to a0 plus a1, and then you put 3 here, so 3 minus 1 plus a2. So now 3 minus 1, and then 3 minus 3. And again, we should not forget that p of 3 is the same as f of 3, or just 30, okay? So from here we can say 30, the left side, is equal to a naught. We had the value from before. We're gonna just be inputting it. So this is 12 plus a1. So 3 minus 1 is 2. So basically just 2a1. And the whole thing becomes 0 because 3 minus 3 is 0. Okay. So now this is just a simple calculation. So 30 minus 12, we're going to be moving this to the other side, and then 2i1, or just 18 is equal to 2i1, or just a1 being equal to 9. Okay, this is the second value. And for the last one, obviously we're going to be using the value 10 because it's the only value that is given and we haven't used it yet. So p of 10 is equal to 156. All right, and then this is equal to putting x as 10 here. Okay, so again we can write a naught plus a1. So this is 10 minus 1 plus a2, 10 minus 1, 10 minus 3. Okay, so 156 is actually equal to, so a naught again is 12. We found that before. And then a1 is, yes, we put it here, so 9. Okay, also we can simplify. So basically this is a1 and it's 9. And then 10 minus 1 is again what? 9. So 9 times 9 plus a2. This is 9. This becomes 7 because 10 minus 3 is 7. Okay, so from here 156 is equal to, so this is 12 and this is 81. So add both together. So 81 plus 12 is actually 93. Okay, plus 9 times 7 is basically 64a2. Okay, now subtract this from that. So we're gonna be left with, so basically that's 3 and then 63, right? Okay. Okay, so 9 times 9 is actually, we said it's 81. So this is 8. From here we said that 12 plus 81 is 93, 156. Okay, now 7 times 9 is 63, so 63a2. Okay, from here we can say that 156 minus 93 is actually 63 equal to 63a2. From here we can say that a2 is equal to 1 because these two cancel. Now, so the general polynomial p of x is equal to a naught, which is just 12, plus a1, which is just 9, x minus 1. Okay, and then plus a2, which was just 1, then x minus 1, x minus 3. So if you leave it like this, then it's correct. If not, you can simplify it even more, which we can actually do. So this is 12. This becomes 9x minus 9. This becomes, let's see, x squared minus 4x plus, I think 3, yes. So this becomes what? X squared, 9x minus 4x plus 5x, and then 12 subtracted by 9, 3. 3 plus 3 is 6. So this is the final polynomial which you can use to approximate the other values of f of x here.